Good afternoon, ladies and gentlemen. Thank you all for coming. My name is Joshua Hernandez, and today I would like to share with you one of the most interesting topics for me, a great study field that has many opportunities, which is speech recognition. Part of my speech, at first, I'm going to share with you the reason why, the motivation behind my interest for this field. And secondly, I'm merely but going to touch the theory behind the technology. But I'll try to keep it as simple as possible. Okay? So, actually, speech recognition is probably in most of your pockets already. If you use smartphones to ever look for restaurants or to make a new memo note by, instead of typing into them but rather speaking into the microphone, this would be considered as part of speech recognition. Nevertheless, this is not the reason I am interested in that field. Let me tell you my two motivations. The first one was a couple of months ago. I was trying to learn a new language, and I already knew how to speak and read. Nevertheless, typing was quite difficult. Why is that? Because different languages have different layouts of keywords. And it can be very, very frustrating for our brains that are already used to one keyword to go from another one. And here I'm showing you the Russian phonetical keyboard, so it should be as close to the sounds that we already know. Nevertheless, we have these two keys, the X, that you would usually expect it to find it on the left corner, but in this case it's on the right. And we also have other keys that happen to be not even in the range that you usually type letters, but rather on the punctuation marks. And after trying to deal with this problem, trying to learn the layout, I discovered a new technique to bypass this problem and just starting to speak to the computer instead of typing, which was ideal. My second motivation is a little bit more serious. It deals with the integration of deaf societies into, specifically into classrooms, right? So imagine yourself as a impaired hearing person, and you sit on the front row of the class and pay attention to the professor that is giving a lecture, and you have developed the ability of lip reading, which is amazing. Nevertheless, sometimes the professor will turn around and keep on talking, but even though you can hear me talking, even though I'm giving you my back, deaf people cannot. And at this point, this technology is already applicable by the use of a common microphone. Most of the lecturers in this university utilize a microphone while giving a lecture. So connecting this microphone to a speech recognition software could easily give the text to the deaf students in their mobile devices. So these are my two motivations. I hope that in the future you might share them. But next I would like to get more into what's behind speech recognition. In very broad terms, speech recognition is basically taking a voice recording and transforming it into text. The steps to do so might seem complicated, but for someone interested in the topic, it's important to not lose the eyes on the goal, which is going from a recording text. Keeping this in mind, I'll continue explaining that speech recognition is actually very interesting in the sense that it's a conversion. It's a field that converges in the intersection of three big fields, that is linguistics, mathematics, and computation, computers. And I'll explain how each of these fields plays an important role in speech recognition. First of all, my favorite part is linguistics. And I would like you to imagine that your voice is music, and that your lungs, throat, tongue, teeth, they are the instrument that produces that music. This whole these body organs are called in all together the vocal tract. So imagining the vocal tract as an instrument, we can see it produces sound waves. And in here we have a comparison between different instruments, a tuning fork, a flute, someone speaking, and a violin. They are actually producing the same frequency. Nevertheless, the waves look very different. That is because, in comparison with the tuning fork, which is only made out of one frequency, most instruments are an addition of other frequencies. So our human voice is rather similar to a violin. And well, continuing with this analogy, the reason that we have different frequencies is because our vocal tract can be thought to be a tube. So depending on how many waves fit on that tube, we can have a broad range of frequencies. And here I would like to introduce to you, for those who it's first time seeing it, the International Phonetic Alphabet Chart, vowel chart for English, for standard American English, taking a slight deviation from the main point, but nevertheless it might be of your interest. In difference with Japanese, which only has 5 vowels, English, in one of its dialects, possesses 11 vowels. So it might come in handy next time you would like to improve your pronunciation. Nevertheless, going back to the main point, I have told you that we can produce different frequencies, and combining them together turns out that the vowels that humans produce are a combination of these two frequencies. And if we plot a graph with the first frequency, with the fundamental frequency going from top to bottom, and the second frequency going from right to left, we get this distribution of frequencies. And actually the interesting part of this chart is that it was developed even before the introduction of the frequency theory behind vowels. Moving on with the mathematical theory, for those who are in the engineering department, you might as well be even more fluent in this topic called Fourier series, which in very broad terms, we have a trigonometry, the fundamentals of this theory are based on trigonometry. We all learned trigonometry in high school. And what we do is we take a very complex wave and break it apart into its fundamental, strongest frequencies. And as you can see, the complex wave breaks down into a number of smaller waves with less strength, which as overall form our voice wave. So let's go a little back. We have a voice recording, and through some we now know that we need the frequencies. The linguistic theory tells us we need frequencies to understand the vowels. So we now break down the vowels using the mathematical theory. And now that we have break all these parts, we need to put them back again in the form of text. The computer, what does is takes one phoneme, that is one sound, and matches it with one letter or one word, if it's a combination of sounds. And the way that people develop or solve this problem, this very complicated computational problem, was well, they were inspired by the human brain. They were inspired by the human brain, how we are able to adapt, to learn, to change the connections between our neurons to understand the world. So what this does, and this is a very nice picture that I found. I guess it gets the idea that neural networks are a connection of little dots that in the end get us an answer. It actually looks like this. This is one of the possible layouts that neural networks can have. And basically we have an input, an output, and something in between happens. We don't really know how it works, but it works and it learns. And overall, today I have showed you some of the important theories behind speech recognition, but also I have shared with you my deepest interest and my motivation behind this topic. I really hope the seed of interest has been planted in some of you, and that will you pursue maybe this field of study. Thank you all for your attention.